This video is going to walk through a sample Python program that converts binary numbers back and forth to decimal numbers. The intention of this video is for a new Python programmer to see a working Python program in action, not as much understanding every piece of what we're going to see, but just seeing an overview of what a Python program looks like and how you would use one. So this program specifically is going to present a menu to the user, and if they select the first option, they'll be able to convert a decimal number to a binary number. And the second option would be the inverse. They would enter a binary number and that would get converted to a decimal. So we'll talk about the documentation inside the program. There will be a docstring explaining what the program does. We'll talk about the user interface, how we get the input, the logic behind the number conversion. We'll print that converted value, and then we'll also talk briefly about error handling, which we'll have a simple example of in this program. So here is our binary.py program. We have a docstring, we print a menu, and then we have some logic. So let's walk through this piece by piece. So the idea is that this docstring helps other programmers understand your code. You can see that it's offset by triple quotes. It includes author and date information. And the idea is to document what the program does. And not just for other programmers, but also for you. If you write a program and come back to it several years later, you won't have the same context to understand what the code does. So using good documentation practices helps you as well. Next, we come to the user interface part of the code. And there we're using the print function to display text to the user. You can see that we have 3 print statements. We say what the program does and then give 2 options. And then we use the input function to get input from the user. The user will enter 1 or 2, and we store that in a variable. This variable is called choice. Now when we use choice in our program, Python will know to use the value that the user entered here. And then finally, we're going to talk about the logic of the program, where we look at what the choice is and make a decision about what to do. So we use this if statement to check what the value is, and here we're checking if their choice was 1, then we're going to have them enter a decimal number. Notice here we're not just using the input function, we're also calling int, which converts their input to an actual number. When you type in, say, a 6, you're actually getting the character 6, not the number 6, which is something that we'll talk about later. But just know that if you want to get a number and use that as a number, then you're going to have to convert it using the int function here. Once we've done that, we convert the number to a binary, because when it converts that number, it's going to read it as a decimal. We convert it to binary using the bin function. Since Python needs some way to know, are you talking about a decimal number or a binary number, it puts a 0 and a b in front of the digits of a binary number to differentiate it from a decimal number. So it knows, oh, this is 2, not 10. We want to remove that in our output, and so this little weird 2 colon in brackets, that's actually the part that does that. When we get to talking about strings and lists, we'll talk about what's going on there. But the key is that Python is doing this work for us. And that's an important concept to think about. It's important to know how to do things in programming, but it's not always important to necessarily do those yourself. Very often you'll have a function or a library that does that thing for you. And in practice, it's better to use those library functions because they're probably going to be more robust and you don't have to worry as much about testing the code yourself. Now, as you're learning, of course, you want to learn how to do these things because you can apply the concepts that you learn by building these functions elsewhere. And so there is a difference between what you do when you're learning and what you do in practice. So again, it's a really subtle distinction there, but it's important that you understand that. And again, as you're learning, you want to do these things for yourself so that you see how things work under the hood. And then in practice, in your career, or when you're building something on your own, that's when you can think about using these built-in library functions. Then if the choice is 2, and here elif means else if, so if it's not 1, if the choice is 2, then, and you'll notice most of this is the same, except that here we call this int function, and then we pass in binary. Binary is the variable where we store the user's input, which should be 1s and 0s, and then we tell the integer function, hey, convert what's in that variable binary, but it's in base 2. So you have to remember that when we say 1, 0, that's 2, not 10, because we're using base 2. And so the int function lets you tell it what base the input's in, and it'll return that as a decimal. And since it's returning a decimal number, we don't have to worry about removing the prefix. And in the last case, we're checking to see if they gave us an invalid input. So here we say else. If it was a 1 or if it was a 2, we would have already handled it. Here, our else case, they've entered something that wasn't a 1 or a 2, and we're going to say invalid choice. Now, there's some other errors that could happen here. So for example, what if they enter a word instead of a number? And so we can have some other issues that could crop up. And when we get to talking about exception handling, we can talk about how to do those. But it's always good to get in the habit of writing code that handles errors, because if an error can happen, it almost always will. And so it's good practice to write code that expects the unexpected. I know I want them to give me a 1 or a 2, but what if they don't? Also notice this as invalid choice. It's always good when there's an error to give helpful feedback to the user, or maybe if you're writing a backend program to log a message indicating what that error is. You don't want it just to say, hey, something went wrong. It's best to say the number was wrong, the number was too big. Maybe even in this case, say, please enter a 1 or a 2 or something like that. So let's run this program. And you can see I've already run it once. So we'll convert a decimal to a binary. I'm going to enter a 1, press enter, and I'll give it a decimal number. And you can see it converts that to a number. So now let's run that again. And I'm actually going to copy this number. Oops. And that's I gave it an invalid thing. I wasn't ready to enter the binary number yet. So you'll notice it says invalid choice. So let me run this again. And I'll say binary to decimal. And I'll give it that binary number I got. And notice it's 5,324, which is the number I entered up here. And so you can see this code actually, it did the conversion back and forth like we would expect. Now there's some other things we could do to enhance this. So for example, we could say, do you want to do another? And then if so, we can repeat. That's a loop. And of course, there's better ways to enhance the design of this program. But really the idea of this example is to see a Python program in action. So it's a lot to see it first if you haven't seen a Python program before. But keep in mind, we will actually come back with other examples and talk more specifically about what each of these pieces are so that you're able to build programs like this on your own.